Hello everyone, welcome to software engineering class. Today we will start chapter 1 and we will follow the textbook of Hans van Lieth. So let's start with some failure stories. You might wonder why failure story? Because the story teaches us that software engineering has many facets. They are not only caused by a technical slip in some routine, they are not only caused by bad management, they are not only the result of human communication problems, it is often a combination of many smaller slips which accumulate over time and eventually result in a major failure. Let's talk about Ariane 5 Flight 501. The flight took place on June 4, 1996. After about 40 seconds at an altitude of less than 4 kilometers, the launcher broke up and exploded. Do you know why this happened? Let me tell you. It's interesting. This 500 million loss was ultimately caused by an overflow in the conversion from a 64-bit floating point number to a 16-bit signed integer. Let me tell you the full story, and your task is to find out the smaller slip which result this major failure. The story is the altitude of the launcher and its movement in space are measured by an inertial reference system (SRI). There are two SRIs operating in parallel. Their hardware and software is identical. Most of the hardware and software for the SRI was retained from the Ariane 4. There is a catch. Most of the hardware and software was retained from Ariane 4. The fatal conversion took place in a piece of software in the SRI, which is only meaningful before liftoff. Though this part of the software serves no purpose, after the rocket has been launched, it keeps running for an additional number of seconds. This requirement was stated more than 10 years earlier for a somewhat peculiar reason. It allows for a quick restart of the countdown in the case that it is interrupted close to liftoff. This requirement does not apply to Ariane 5, but the software was left unchanged because after all it worked, right? Since the Ariane 5 is much faster than Ariane 4, the rocket reaches a much higher horizontal velocity within this short period after liftoff, resulting in the above mentioned overflow. Because of this overflow, the first SRI ceased to function. The second SRI was then activated, but since the hardware and software of both SRIs are identical, the second SRI failed as well. As a consequence, wrong data were transmitted from the SRI to the onboard computer. So now you know why wrong data was sent, why this overflow has happened. So now that you know the story, can you tell me the possible explanations? Okay. The possible explanations are given here. Inadequate testing, wrong type of reuse, wrong design philosophy. These were small slips. So let's talk about inadequate testing. It was a software failure, right? So as it was a software failure, it could have been revealed with more extensive testing. And the investigating committee managed to expose the failure using extensive simulations. So that means there was lack of testing. So this was one reason. And the next reason we could say improper use. Okay, this failure was caused by reusing a flawed component. They used the component in Arraign 4, but because of physical characteristics of Arraign 4, these flaws had never been apparent. There had been many successful Arraign 4 flights using essentially the same SRI subsystem, but Arraign 5 failed. So apparently the successful use of a component in one environment is no guarantee for successful reuse of that component in another environment. So that was a wrong type of reuse. And talk about wrong design philosophy. This failure was caused by a flaw in the design. The Arraign software follows a typical hardware design philosophy. If a component breaks down, the cause is assumed to be random and it is handled by shutting down the part and invoking a backup component. So they used this philosophy. In the case of a software failure which is not random, an identical backup of it is of little use, right? For the software part, a different line might have been allowed. So that was wrong design philosophy. So if you want to know more about this incident, you can click this link over here, and there are three more disaster incidents listed in our textbook, so you can also read from there if you are interested. So now that you know that failure in software development projects often are not one dimensional. Success in software development will not come about if we just employ the brightest programmer, or if we just apply the newest design philosophy, or have the most extensive user consultation, or even hire the best manager. To be successful, you have to do all of that and even more. So that was for today. We will see you in next class. Thank you.